2013 Ford Explorer. Customer complaint is check engine light is on, and at times check engine light does come on and off, and during pumping gas they are unable to pump the gas. The pump keeps shutting off on them. So let's scan the car and see what codes we have. Okay, so got P0446 EVAP system vent control circuit fault. So let's look at the wiring schematic. Okay, so here we go. That's wiring schematic for the Explorer, and this is our vent valve right there. PCM supplies the ground. It's a ground side switch, and we should have constant 12 volt hot at all times. So I should have power at all times, and whenever PCM decides to supply ground, this vent valve should close. Normally vent valve is open. Once PCM commands sends the ground, this would close, and it'll do its leak pressure test, see if system has a leak or not. So let's check our power and see what's going on with the circuit. Okay, so I'm under the truck. That's where the canister lives. That's our vent valve right here. Alright, so here's the setup. So I'm getting power and ground right from the battery. The extension wire is going, and the canister lives right there. You can see my yellow lead that goes to my scope. So our ground and red wire show constant power. So let's crawl in there and see if our connection is good. Okay, so that's the brown and red wire I'm at, and I do see 12 volt. Okay, as you can see, it's 12 volt right here, and the other wire should, if the solenoid is not grounded, it should have 12 volt on that too. So let me put my pin there and show you guys. And we do not have 0 volt. We do not have 12 volt. What we have is 1.5 volt shown. So is PCM constantly grounding this valve? And let me show you guys what I'm seeing on the scope. 1.46 volt live. According to the diagram, our should have 12 volt if PCM is not supplying the ground. Should have 12 volt. Voltage travel through this valve, and 12 volt should come out of this. Once PCM supplies the ground, then the voltage should drop on the valve. Right now we have constant voltage drop. Let me disconnect that. Let me disconnect the vent valve and see what happens. Okay, let me just disconnect this. Come on. Oh, I heard something clicked. Let's see. Let's see where we are. Let me plug it back in. Wow. Okay. You guys can hear it. Hopefully my phone can pick it up. So let's see what the heck is going on with the ground side of it. We probe that. It should not have any voltage. Okay, so I'm on the control side of the pin. Meter is hooked up to the ground. Got 0 volts. So as soon as I plug it in, it jumps to 1 volt. which it should not. Let's see if I can do this with one hand. Trying to plug it in. Yeah, so 1.5 volt. Let me see, 1.47 volt. So let me grab my test light and hook my test light to battery positive, and let me disconnect this, and my test light would be on the one side of the positive and one side would be this. See if my test light stays lit or not. Okay, so I got a 350 milliamp bulb. So let's connect one side to the vent valve control side of it, and the other side of the bulb will be on the battery positive. So let me set it up. Okay, so the one lead goes to the control side of it, and the other side is the battery positive, and you can see the light is lit. Key is on right now, and voltage went up to 1.8483 volt. So let me turn the key off and see if this light goes out or not. Okay, let me do that. Actually, before turning the light key off, let's activate the control valve. See what happens. The vent control valve. Okay, EVAP canister vent valve. Let's do that. Not needed, so hit cancel. Okay, so right now it's off. So technically the light should be off. Okay, let me turn it on and see what happens with the light. Okay, it's on right now. Voltage stays the same. Light still on. Just turn it off. Did not do anything. Okay, let me turn the key off, see what happens with that bulb. Okay, so the key is off and lights stays on, stays lit, still at 1.82 volts. And let me show you, key is off. As you can see, key is off. There's the keys. So is the circuit shorted to power? Let's look at the diagram where the connectors meet and what's the next logical best step to take. Okay, so our connectors are C3053. They share the same connector, power, and the ground side of the circuit. So we worry about the ground side of the circuit, right? So 3053, let's see where that resides. Then 213, and then 1551B to PCM. So let's look up 3053. Let's see where we at. So 3053, that's by the gas tank. You gotta lower or remove the gas tank. And the second connector, which is C213, and it says is by the left kick panel. So yep, so that's where it resides. So let's see where this. Okay, 1551B is by the, that's a PCM connector. It lives under the wiper cowling. So I gotta remove the wiper arms, cowling, and should be able to gain access to the PCM. So I think what I'm gonna do, I'm gonna gain access to that because this is much easier and less trim panels to take off than dropping the tank down or lowering the gas tank down. The thought process behind this is if I were to disconnect the PCM, light should go out. If it does go out, then we know PCM is internally grounding the circuit constantly. If the light stays lit, then there's a short somewhere externally. So let's do that. Let me take the wiper cowling out and gain access to the PCM. Okay, so I was able to get the wiper cowling off, and I was able to find a pin. Which pin goes? It's a pin 20. It is a green and blue and green trace. So So I got my test light hooked up to the positive. Once it finds a ground, it should light up. Let me find a good ground. There you go. And let's see what happens. Okay, so light still stays on. So right now key is off. There should not be any light. So let me disconnect this, see what happens. Let me use my other hand as well. Okay, so let's unlatch this. And my light just went out. Okay, so no light. Let's look at the light at the bottom of the car. No light. So let me connect the PCM again and we will revisit this light again. You can see it's jump back up to 12 volts. So let's reconnect our PCM. Okay, here we go. PCM connected. Well, it's our test light. And let's see what's happening with our light. And on. And went down to 2.15 volts. So yeah, car's gonna need a, looks like car's gonna need a PCM. Boy. Okay, so I will recommend definitely a PCM, needs to be programmed, and then the vent valve, just to be in the safe side. Maybe vent valve has something to do with taking out the PCM driver, I'm not sure. So I'm definitely gonna recommend vent valve as well. I will let's see what the customer wants, and I'll post the fix in the description, so look for that. Hopefully we learned something, and yeah, that's it.